Okay, so we're interested in where the this graph has a tangent line which is horizontal. So again, what's my explanation? Well, my explanation, if this is the function, I'm interested where the tangent line is horizontal. The explanation is to find x such that f prime at x is equal to 0. So we need the derivative here. The derivative is going to be 60x squared minus 10x minus 50, and we want to set that equal to 0. Okay, now make your work simpler. We want to divide everything by 10, which gives us 6x squared minus x minus 5 is equal to 0. Now factorize. Alright, so we want to figure out how this is actually going to work. So let's try, what if we try 3x and 2x? 3x and 2x, will this work? Yes, I think 15, 2. No, that's not going to work, is it? Okay, so we want to have 6x and x over here. Okay, and then this is going to be 5, and this is going to be 1, and then this is going to be minus, and this is going to be plus, and we set that equal to 0. So therefore we get x is equal to negative 5 over 6, or x is equal to 1. Alright, so there's the two x values for which the tangent is horizontal. Alright, we can find the points in a minute if we actually substitute these back into the original function, but in the meantime let's check our calculator to make sure that these answers make sense from a graphical point of view. So we'll go to our calculator and we'll clear everything on here. So we need to go to our second function, draw, and clear the draw features, and then we're going to go change our window as well, or our function. So we have 20x cubed so it's 20x cubed minus 5x squared minus 50x plus 3. Okay, and we need to find an appropriate window to see this entire function. So I'll start with zoom standard. And you can see that zoom standard isn't a really good window. I need to change my y values, my y max, my y min. But I can also see that I can change my x values and make them a little bit wider here. So I'll go to my window, and let's go between, let's say, negative 5 and 5. Okay, and now I need to find an appropriate minimum and maximum. Okay, so let's try negative 50 to positive 50. Let's see what that does. That seems to be okay. And we'll go with a scale of 10 here. And if I graph, you can see that there's my cubic function. We know the general shape of a cubic, and you can see that it has a max and min, and therefore there's 2 points where the tangent should be horizontal, right? One of those points should be where x is negative 5, 6, and the other one should be where x is equal to 1. So let's just check. We're going to draw a tangent. So second draw, and then we go to a tangent, and let's put in negative 5, 6, negative 5, 6, and hopefully we get a horizontal tangent at one point, in this case at the maximum. And then let's draw another one. So second draw, the other tangent's going to take place when x is 1, and we hit enter, and therefore we also see that the tangent is horizontal. Again, be careful of this coefficient of x here where it says 2e to the negative 5. That's essentially 0.00002, which is essentially 0. Okay, so we have to make sure that we understand that that is 0. Alright, and the y-intercept here is negative 32. It's not negative 32.00002. Again, this is how the calculator approximates our solutions, okay? But we got to understand that it's actually negative 32. This is about getting to know your calculator. Okay?